Hello! Welcome to PhySeeks. For today's episode, we'll be talking about electric charges. Electric charge compose many aspects of our world prominently in electricity and lightning. It is a fundamental property of matter that describes the inherent positive or negative nature of particles, determining their interactions with an electric field. Negative charges are called electrons, whereas positive charges are called protons. And neutrons, they exhibit no charge. Remember, only electrons move and transfer. Opposite charges attract. Similar charges repel. In today's episode, we'll present you 3 DIY experiments designed to explain the movement of electrons and electric charges. These experiments are Wingardium Leviosa, electrophorus, and electroscope. And through this, we'll learn about electric force, electrostatic energy, and the methods of charging, namely friction, conduction, and induction.
However, let's recall the fundamental law that governs the interaction between electric charges. Coulomb's law. Coulomb's law states that the force between two charged objects is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. So, the closer the charges and the greater their magnitudes, the stronger the force. Let's see this law in action with our electrifying experimentations.
Wingardium Leviosa from the famous Harry Potter. For this experiment, we will be needing 3 different materials.
Cloth, string, PVC pipe.
Cloth should preferably be made of a material like wool or polyester so that it can easily accumulate charge. One end of the PVC pipe firmly and briskly wrap the cloth along the length of the pipe for about 30 seconds or a minute. The friction between the cloth and the PVC pipe causes the transfer of electrons from the cloth to the PVC surface, resulting in the PVC becoming negatively charged. Take the piece of string and rub it against the cloth you are wearing for about the same duration as the PVC pipe. This transfers electrons from the cloth to the piece of string, making it negatively charged. Once both the PVC pipe and the piece of string are charged, hold the charged piece of string near the charged PVC pipe without touching them. When you bring the charged piece of string near the charged PVC pipe, they both repel each other. This repulsion occurs because both objects have acquired a negative charge. And remember, according to electrostatics, like charges repel each other. This repulsive forces causes the piece of string to fly or be repelled away.
This experiment begins by assembling the electrophorus. To assemble the electrophorus, you must attach the styrofoam cup onto the aluminum plate facing downwards and taping it afterwards to secure it. To begin the experiment proper, we must wipe the styrofoam plate with the wool cloth or the t-shirt to charge it. This allows the charges of the styrofoam plate to attract to those of the aluminum plate. This time, place the electrophorus on top of the negatively charged styrofoam plate, then carefully press your finger onto it. This will enable the exchange of electrons from your finger to the aluminum plate, causing both of the plates to stick together once elevated. Now, repeat this process for several times and notice the attraction of the plates. In this experiment, one example of electrostatics was introduced through the use of everyday or common household items through friction. Friction was exhibited when the electrons from the piece of shirt were rubbed off to the styrofoam plate, which caused it to become negatively charged, attracting the aluminum plate. This was also displayed when we placed our finger in direct contact with the plate, allowing for the exchange of electrons. In essence, exploring the underlying principles of electrophorus has clearly depicted the relationship between positive charges and negative charges, such as the transfer of electrons from one object to another, as well as the concept of attraction.
To create an electroscope, you will be needing the following materials: aluminum foil puncher, scissor, glass jar, copper wire, PVC pipe, cloth, and a screwdriver. In assembling the electroscope, you must fold the aluminum foil in half and trace out a leaf-like shape. Cut it out and punch a hole in one side of the paper. With a screwdriver, carefully poke a hole through the cap. Insert the copper wire into the hole, shaping it accordingly. Hang the 2 pieces of aluminum foil you've prepared earlier on the wire. Then, Charge your PVC pipe by rubbing it against a cloth. Then, place it on or near the wire. As a result, your papers or aluminum foil will repel each other. By rubbing the PVC pipe with the cloth, it transfers electrons from the cloth to the PVC pipe, giving the pipe a negative charge. When the negatively charged pipe contacts the copper wire, the papers repel each other due to the presence of the like charges. Upon touching the copper wire with our hands, the papers release or collapse, indicating that the electroscope is discharged. This happens because touching the wire allows the negative charge to flow to the ground, effectively discharging the electroscope.
In retrospect, these 3 DIY experiments have elucidated key concepts of electric charges. Wingardium Leviosa uses static electricity and friction to show how electric charges transfer. Rubbing PVC or plastic bags against clothing creates friction that enables electron transfer between materials, which shows static electricity principles. Electrophores demonstrate friction and induction in electrostatics. Friction transfers electron from wool to styrofoam, creating a negative charge that attracts aluminum. Induction is shown by a finger near the positively charged aluminum plate connected to negatively charged styrofoam, showcasing the interaction of positive and negative charges. Lastly, electroscope. By rubbing a PVC pipe with a cloth, electrons are transferred, giving the pipe a negative charge. Touching the copper wire discharges the electroscope by allowing negative charge to flow to the ground, showing the principle of charge transfer and discharge. Through hands-on exploration, we've delved into fundamental principles in physics with broader implications for technology and engineering. This shows the importance of electrical phenomena in our daily life.
As we conclude this episode on National Geographic, we invite you to continue your quest for knowledge in the vast expanse of physics. Remember, the pursuit of understanding is an endless journey, and in science, there will always be more questions than answers. We hope you join us in the next episode of PhySeeks, where we continue seeking answers in physics and the rest of the scientific world.